Okay, are we back on?
Yes.
All right, let me share that whiteboard with you again. Okay, so we were saying what we know. We had a flow rate of was 0.7 mgd. And we also had the dosage. And this is chlorine gas, so we are assuming that is 100% available chlorine. That's how the gas behave. And they say it's a constant flow. So it's 1.2 milligrams a liter. So as I said to you, million gallons per day or over day by 8.34 pounds per gallon by your dosage, which is 1.2 milligrams per liter, will give you the amount of pounds in a day. Okay, I start off by saying in one day, because you have day here and day here on both sides of the equation. So you're getting how much pounds in this one day. So we're talking 0.7 by 8.34. That must be able to tell me how much pounds in a day. Somebody work on that. I'll work with you again to make sure it's correct. £7 per day. Cents. Any doubts? Straight ahead. We have two more illustrative examples that would take you how they would vary. And I'll put what I'm doing here in context with the formula that as it will be in the sheet. Remember, this formula is the same. We'll just put it in a nice way. And inside that formula, remember this here, this part here is the dosage. Remember, here is the flow. And actually, pounds per day is what you call the feed rate. The feed rate, the dosage. And this is the flow rate here. This is the flow rate. So take note of that. MGD will be the flow rate, the amount of water passing per day. In our case, and for all intents and purposes here, million gallons per day. We know this conversion is the amount of water you have in the amount of pounds in 1 US gallon of water. That's not a problem. And here we have, as I said, this is always the dosage here. Milligrams per liter or parts per million, ppm. And over here is pounds per day. That's what they call the feed rate. Okay? So bear that in mind. We as operators had to be able to have that and we fingertips. When we see the mathematical problem, don't panic, but we know what we're talking about. That's why I'm doing it, what I call from first principles, so you'll understand it. Okay? If no doubts, I want to move on to illustrative example number 3. If you have any doubts, put it in the chat. I hope my calculation is correct here now. 7 pounds of chlorine. All right. So it seems that we can move ahead. Alvin, any questions on the chat?
Not so far.
Okay. So we're moving ahead. I'm cleaning this up. I guess you have it. Again, you'll take the question down. 2 lines. Again. Chlorine is added at a rate of 10 pounds.
We're not hearing you at all.
Alvin?
Yeah, we could not hear you at all.
Alvin?
Yes, I'm right there.
Okay, you hearing us? You hearing me?
Yeah, I'm hearing you now. Yeah.
Okay. Chlorine is added at a rate of 10 pounds per day to a flow of 300 gallons per minute. If the chlorine residual in the system is 1.5 milligrams per liter, comma, what is the chlorine demand? Question mark. So this is the question. Let's make sure we all have it.
Yeah, I posted it in the chat.
Somebody saying something?
No, I said I typed and posted it in the chat.
Right. Chlorine is added at a rate of 10 pounds per day to a flow of 300 gallons per minute, full stop. If the chlorine residual is if the chlorine residual in the system is 1.5 milligrams per liter, comma, what is the chlorine demand? Okay, what do we know? There's something new there that I want to introduce. Actually, we'll introduce the 2 formulas as we see it in the formula sheet and in the literature. Let's see what we know first. Okay. So in terms of the known and the unknown in the corner here. They say chlorine is added at a rate of 10 pounds per day. Remember what that was? That's the feed rate. And you remember the feed rate was on one side of the equation? The feed rate is 10 pounds per day. 10 lbs per day. And we know the flow rate they say the flow rate is 300 gallons per minute. Demand. So what we the unknown is the demand. We don't know the demand. Question mark by the demand. And this demand, I guess, milligram liter. Milligrams a liter, the demand would be, or ppm, milligrams a liter. Okay, a few things. First of all, I want to bring my flow rate, which is 300 gallons a minute. I want to put this as million gallons a day. You could do it from first principles. You could say 1 gallon a minute. Think about a minute. Think about a day, right? 60 minutes in an hour, 24 hours, 1 day. I'm saying to you because I think you have more, is wiser. It stays with you better if you go from first principles in your head. Paper. 60 by 4 minutes. That's 1440. You could check that on your calculator. Or and then we going from gallons a minute to we're going from gallons a minute to million gallons a day. So common sense, we must get a fraction. 300 gallons a minute in million gallons a day, you must get a fraction. So if you're going wrong, the mathematical analysis would point you to your common sense. And better yet, on the formula sheet that they have it, actually, what I'm saying to you, 60 by 24. If you use your calculator and you get that 1 over 1440, you'll see what I'm talking about. I hate to just jump into that, but at least at your level, that's what they give you. If you find the reciprocal of that, you will see what we're talking about. And from the formula sheet, it tells you that 1 million gallons. So this is just a pinpoint for now for you to remember where it's coming from, not coming from the air. 1 mgd is 694.4 GPM. You could check it out. I'll just show you the way to get that back from first principles. So if we have 300 GPM and we divide that by 694, because 1 GPM is 690, you will see gallons per minute is the same as 0.432 mgd. Tell me if you have a doubt to that. All right, tell me if you have a doubt, because just now I have trouble. I want to bring back the formula that I tell you, you have it already. mgd, and this is significant because I'm going to rub off and put it in the form of the formula, or you see it on the formula sheet is the same. mgd, let me clear that up so that you don't get confused. mgd, million gallons a day. Remember that, I'm putting it down again, you have it already. 8.34 pounds per gallon by your dosage in milligrams a liter. We'll always give you a feed, which is pounds per day. Right? You have that already. I'm just reminding you of the formula. Now, they said that, and I suppose you would have do it in your chlorination, Mr. Alvinus, you would have mentioned it when you spoke about, for example, your brick pan chlorination, chlorine, you always chlorinate. Whatever you do, you chlorinate to bacteria and so on. Distribution system. So this formula I'm going to put down here for you is not new. Remember that your chlorine dose
Yeah, we mentioned this before. It is also on the WASO online.
Right. So your chlorine dose, and I'm writing it out, but I want it to be foremost in your mind. Your chlorine dose would be equal to your chlorine demand. Let me take that off. Stylus giving trouble. Your chlorine demand, sorry. Demand plus your residual. Okay, so remember this. Foremost in your mind, this comes to mind. All right. Okay. Now this fella here now, this one here. When you go on your formula sheet, you would see it as, and it's just a matter of transposing. You have the feed here. You have the, as I say, you have the flow here, and you have the dose here. So if I make the dosage the subject of the equation, or in other words, I'm expressing the dosage in terms of other things that I have in the feed and the flow. This is what the formula does. And you'll see straight away that the dose, and that's where you come from. And that's in milligrams a liter. This dose in milligrams a liter is equal to your feed. The formula doesn't say feed, but remember it's the feed. It just said pounds per day. Let me make some more space. Pounds per day all over, which is your feed, divided by your flow rate, million gallons. I'll clean that up. Million gallons per day over or multiplied by the 8.3 you had, which is pounds, 8.34 pounds every gallon. And that's what it is. Remember you had as a data your feed, which was pounds per day, was 10 pounds per day. With gallonage now was, with million gallons per day, we got it as 0.432 multiplied by that constant, which is the weight of water of a US gallon of water. And this will give me my dosage. So transposing in the formula that I had is the same thing. They give you that straight away in the formula sheet. That your dose in milligrams a liter is pounds per day, mgd multiplied by 8.34, still dividing. Tell me if we clear on that. And when I get that, remember, that's what you're dosing, but they ask you for the demand. Okay? I could take this piece out here now. All right? The dose, I guess by now you work it out. 10 divided by 0.432 divided by 8.34 should give you 2.78 milligrams a liter. This should be a dose. All right? But they didn't ask us the dose, they asked us for the demand. But you need to calculate the dosage. They give you enough information to find the dosage first of all. Okay, I guess I could take this formula out here now. Everybody have it, and it's on the formula sheet. Chlorine demand, which is what they ask us for then, you have a simple equation. If chlorine dose is equal to chlorine demand plus residual, then chlorine demand, make chlorine demand the subject of the equation as it were. Chlorine demand would be equal to the dosage. The dosage minus the residual. Right? The demand dosage minus the residual, because simple arithmetic and transpose. So that will be the 2.78 we got, minus, they told us that the residual in the water when we measure it was 1.2, is it? Was it 1.2? 1.5.
1.5.
1.5. So we end up with a 1.28, which is for all intents and purposes the one decimal place 1.3 milligrams a liter. And that's how the problem in the exams will come. So practice it. They're straightforward, but you have to remember, if you're good enough and you just want to remember the formula, you don't have to remember the formula because they're giving it to you. If you have a doubt, you could put down the first principles and work it and get it. So the chlorine demand is 1.3 milligrams a liter. Any doubt to that? Anything that burning? If not, we go on to the last illustrative example.
There are no questions here.
We go on to the last illustrative example, which has a different variant too, which always would come. You will always get questions along those lines. So moving on. Okay. Illustrative example 4. It says, how many pounds of 65% chlorine and in bracket you have high test hypochlorite. You'll see that. Sometimes if you go and buy, if you're buying tablets for your swimming pools, or even though if you're working on what the utilities you usually buy, the hypochlorite, you'll see that mark on it. So take it again. How many pounds of 65% chlorine and in bracket HTH be needed to treat the same amount of water as 10 pounds of 100% chlorine. So let's see if we get it. Running it over. How many pounds of 65% chlorine in bracket HTH? And I said, if you don't know it, you learn it from now. That is calcium hypochlorite. It's a tablet, solid form. Will be needed to treat the same amount of water as 10 pounds of 100% chlorine. So we want an equivalent. All the tablets that we have is only a 65%. What is known and your unknown. All right, they say the feed will finish in 10 minutes. I think we have enough time. So your HTH concentration is 65%. With chlorine concentration is 100%. With the unknown, they want how much pounds. Of HTH, calcium hypochlorite. That they don't know. We want to know that. Pounds of that. In terms of pounds of chlorine, we know 10 pounds was the 100%. And in terms of the hypochlorite, look at this carefully, everybody look at this. The HT want to find, and they give a percentage, you have to divide. But you have to bring the percentage to a decimal. 65% is 0.65. So it's 10 divided by 0.65. And remember the 0.65, this is available free chlorine. The percentage of Cl2. So 10 divided by 0.65, everybody will realize that we get, that is 10 over 0.65. We will get a number bigger than 10 because we're dividing by a fraction. Everybody clear on that? That should give you 15.38 pounds. Simple question, important question for an operator on a plant. Simple maths. That is 15.4 pounds. Rounded off to 1 decimal place. And I want to tell you it's simple, but you have to know what you're talking about. And you have to relate this into practice. It's obviously that the HTH tablets is not pure. I see they have some these days. Now I still have some. I bought some the last time to do some work. I think you're getting up to 0.9% now, 99, some of them. It only has, in this case, this one only have, the available chlorine is only 65%. So you need more than the 10 pounds to get out the same dosage if you're using, or if you want to substitute the chlorine for the chlorine hypochlorite tablets. So 10 divided by 0.65. Let me fix that up for you. 1 decimal point would give 15.38 pounds. And believe it or not, that's what they ask you. That's it. If you follow. So this is another variant of how these problems show up themselves in the course material and on the exam. Any doubts? We will have some time to go in. When you do the worksheet, you'll expose yourself to slightly, but in terms of chlorine is so complicated and difficult to deal with already. They don't complicate your matters in terms of calculation. Generally, the questions are usually simple. But when you do your worksheet and to submit it, you'll see other variants. You might see questions that you're familiar with too. Okay? Any questions? Alvin, any on the chat? Alvin, any chat? Somebody hearing me? Tonya B, tell me if you're hearing me.
Alphonsus, I'm on a call.
Okay, sorry about that. No.
So if you don't hear me, it's because I'm on a call.
Problem.
I'll be back shortly.
No problem. We're winding down anyway. All right. Anybody else? Gavin? Ezekiel? Any doubts?
Yes, we can hear you.
Right? Any doubts?
No, sir.
All right. This is a question that I want everybody to get right. And you'll always have one or two of them. Everybody should get that right. And remember, one.
You kind of break off. We did not hear that.
First. Now, if it's the other way around.
You kind of broke up. We did not hear that.
Wow. Let me see. The internet giving trouble. You hearing me there?
Yes, sir. Yes.
Right. I'm saying to you, what you have to remember there is two variants you could get. If they ask you for pounds of chlorine and you have a percentage available chlorine, you're dividing. So you take the 65% in this case and you bring it to a decimal 0.65 and you divide. Now, if this is the other way around, they give you pounds and you want to get out a percentage, you have to multiply. So remember that. So you'll have those two variants facing you and you use your common sense based on what they ask you and apply the question. So this is what I wanted to share with you. If you have any questions, you could ask. But basically, this is what I wanted to share with you for today. I'm not hearing anybody. Okay?
Yes, we good, sir.
All right, good to hear that. And stay safe too. How we going with the lockdown? The whole world on lockdown, you know. So you don't worry. Remember, everybody going through the same thing. Just like that, everybody have to die someday. So don't worry. Everybody getting their share of the lockdown. But abuse of women and violence and men too increase. Domestic violence. So people they're not accustomed 24 hours with their spouse and their boyfriend and girlfriends. Wow. What you gonna do? Make some time, go in a corner and do some work. Now is your time to get an A++ when your exam comes. You have a lot of time. Okay? This is going to cut off. So see you next time. The worksheets, I think you have to submit it. You look for it, it's there. Do it soonest so I could, while I'm here, I'll look at them and go through them one by one, give everybody the individual comments. So all the best. Have a good one and have a good week.
Okay, sir.
Bye-bye.